thank you so much for coming to this lesson. So today we're going to be going over modelling. So it will be really useful if you go over the topics of functions, as that would come into handy a lot for this topic. So the learning objective is to be able to use functions in modelling, including knowing its limitations and refinements. So like always, there's going to be timestamps in the description of the video, so feel free to skip to any parts you want to. So firstly, we need to know what a model is. So a model is just a simplified version of reality. So it's a simplified version to model like a real life situation. So for example, you could have a population model to work out how quick it takes the population to grow over a certain time period. Or you could have a speed model to work out how fast it takes a car to travel from this place to this place in this amount of time. So when you have a model, you have to include, because it's simplified, you always use a lot of assumptions in your model. So for example, if you go back to the population model, you may assume that the population is growing at a constant rate over time, just to make the algebra in your model a lot more simple. But in reality, that might not happen, so you could have like a shock to the system, such as like coronavirus, where there's a lot of deaths, so the population is reducing at a lot faster rate than it would normally happen. So that's just, and if you go on to like the speed model, for example, you're trying to work out how fast a car is going to travel in X amount of time, an assumption that you could use in your model is that you're ignoring that friction between the roads and the car, just to make, again, your maths a lot easier when you're working with the model. But in fact, in reality, there is going to be friction, and that will affect how quick your car is actually traveling. So that is just an overview of what models are. And because of these assumptions that you use, that can mean that there might be a lot of limitations within your model, and therefore you may have to refine your model a little bit to make up for the fact that there may be some limitations. So if you go over an example question, working out what your limitations would be and how you would define it, this would all become a lot clearer. So moving on to an example about using a model and working out the assumptions that you could use. We have this example here. So Leon owns a gooseberry farm. This week he had 5 workers picking fruit, and they picked a total of 1,000 punnets of gooseberries. Leon wants to hire more workers for next week. He predicts that next week, if the number of workers on his farm is W, the farm will produce P punnets of gooseberries, where P is equal to 200 W. Suggest 3 assumptions Leon has made in his model. So feel free to pause the video now and try it for yourself. So we want to try and figure out the 3 assumptions that he's used. So I've laid out the 3 assumptions over here that Leon has made in his model. So I'll walk you through each one. So bear in mind that there are many different other options that you could have chosen. These are just 3 examples of assumptions. The first one is that there will be enough gooseberries to fill 200 punnets per worker. So he's assuming that, so there could be, at some point there could be like only like 100 punnets, or there may not actually be enough for every worker to be able to pick 200 punnets. So this is an assumption he's just made in his model to make the math a little bit easier. And the next assumption he's made is that the weather is good enough to allow each worker to work the same number of hours each week. So he's assuming that the weather is around the same each week. So he's assuming that like there's not going to be any rain, but this could affect the number of hours the workers can actually work, because if there's rain, then it means that they may not be able to pick enough gooseberries, or if it's too windy, or if the weather conditions aren't great. He's just ignored that, and he's assuming that the weather is the same throughout the week. So each week the workers are working the same amount of hours. And then the last assumption he's made is that any new workers he employs any new workers he employs will work at the same speed. So he's not taking into account that some workers may be faster than others or some may be slower. He's just assuming that they all work at the same speed. So a follow-up question to this could be, how could you refine the model, taking out these assumptions which are also limitations to the model. So one example you could say, oh, let's take into account that one worker is a lot quicker, and he has, so then therefore he's able to pick, let's say 300 punnets in a week compared to another worker who can only pick 200. So you can add one way to reduce the limitation of the model is you could incorporate that. So whenever you ask for a question like this, first thing to do is state the assumptions, and then say this could mean that your conclusions may be limited. And then here's a way that you could refine your model by relaxing one of these assumptions. That's just, let's try another question about modeling next. We have a question here on how we can actually apply using model to solve different aspects of the question. So if you don't remember exponentials, then make sure you review that lesson and then come back to try and solve this. But feel free to pause the video now and try it for yourself. So we have a microbiologist is studying the growth of populations for simple organisms. For one such organism, the model prepared is P equals 100 minus 50 e to the power of a quarter t. And the first thing we want to do is write down the initial value of the population. So the initial value of population would just be when the time is 0 because it's starting, so when t is 0. So you just plug that into the equation. You just plug t into 0 to try and find p. So if we do that, we would have p equals 100 minus 50 e to the power of minus a quarter t. And then when t is 0, and then we can just, that e to the power of 0, that's just 1. So this would cancel down to minus 50. So you just have 100, you just have p equals 100 minus 50, which is just 50. So that is just the answer to the first step question. And for the next bit, you want to find the time at which the population will have a value of 75. So that is just when p is equal to 75. So you just plug that in. So you'd have 75 equals 100 minus 50 e to the power of minus quarter t. And then if you rearrange this to bring this expression onto one side, you'd get 50 e to the power of minus a quarter t is equal to 25. And then if we divide each both sides by 50, you'd get e to the power of minus a quarter t is equal to a half. And then if we continue over here, if you ln both sides, that would get rid of the e. So you'd have a minus a quarter t is equal to ln half. And then if you divide both sides by minus a quarter, you'd get t is equal to minus 4 ln half. And then if you plug that into the calculator, you should get 2.8. So that's just the answer to this question. So I hope you found this lesson really useful. So just to sum up what we did, we went through being able to use functions of modeling, including learning how to their limitations and also how to figure out their refinements. So make sure you do some practice questions to fully consolidate everything we've covered. But otherwise, thank you so much.